Now, what we're going to do is we're going to investigate the predictive power of Mendel's periodic table. And to do that, what we're going to do is we're going to look at 4 properties for a number of the elements in the periodic table, and then we're going to use the patterns that we observe to make some predictions about elements that are missing. Okay, so first off, what you're going to do is you're going to have to take the sheet that you're given with the properties and color them so that you can therefore see the pattern. So what we have here is for each element, we have their atomic mass, their color, their density, their reactivity, and their conductivity. And then we have a number of squares underneath that we can use to color code each of these properties. So, for example, if they're colorless, I'll leave the square that I'm going to choose for color blank, but if they're silver gray, I'll color it gray. Or if they're like carbon where they're black, I'll cover the square black. If they have a high density, so in the thousands, I'll give that one color. And medium density in the hundreds, I'll give it another color. And low density, I'll give it a third color. Okay, same with reactivity. High reactivity will be one color, medium will be one color, low will be a third, and conductivity. So let's take a look at how this would work. Okay, so for density, so here for color, if we're looking, so let's take a look at how this works. So for this first one, what we'll do is look at the hydrogen. And so for our color, because it's colorless, I'm going to leave a square for color blank. For density, I picked these 3 colors to represent my different densities. And since it has a low density, I'll give it the color for low density. And then for reactivity, okay, I'll pick my 3 colors for reactivity, and I'll color in the square. The color for its reactivity is highly reactive, so I color it in. For conductivity, it has a low, okay, it's an insulator. It doesn't conduct at all, so I'll color it square red. So I'm going to go through and do that for each of the elements. So first off, you do that. So pause the video, I would suggest, and color in your sheet. Okay, now that you've colored in all of your things, what you're going to do is you're going to take one of the different groups, and you're going to look at the properties to see if you can make predictions as to the chemical and physical properties within a group. So let's take a look at group 18, our last group. Okay, and I'm going to look at all of the elements in this group, and I can notice their colors for their density, their reactivity, and their conductivity. And they're also all colorless. Okay, so all the elements in the last group are, and I could comment on their reactivity, non-reactive. So you're going to make 10 predictions, okay, or 10 observations for different groups. And so you can make observations for a group more than once. Okay, now that you're done making your observations, what we're going to do is we're going to start using those observations to make some predictions. And so what we're going to do is we're going to make some predictions for the element below aluminum, which had its properties missing, right? So if we look at the element below aluminum, its properties are missing. So the first property that we could look at is atomic mass, okay? And what we can do is we can look at the atomic masses of the elements above it and below it, and to the left and right. And so we can see with all of our other groups, as we go down our groups, atomic mass increases, and as we go across our periods, it increases. So therefore, our atomic mass is going to increase between these two groups. Okay? And so if we were to take a guess, I would say that it's less than 70, more than 40, so that's 30, so I'd say somewhere between 55 and 60. Okay, so I'm going to estimate this atomic mass is 60. Next, we'll look at its color. So if I look at all of the elements in the same group, they're all silver gray. Okay, and to the left and right, it's silver gray as well. So I'm going to predict that it's probably going to be a silver gray compound because it's going to follow the pattern. Okay, next we can look at density, and we can see that as we go down the group, our density increases, and as I go across my period, my density increases. So my density is going to be somewhere above 2,700 and somewhere below 7,300. So I'll estimate a density. I'm going to say 3,500. Okay, it doesn't matter the exact value or whether the value is correct. What matters is that I make my prediction, and I use when I'm observing my periodic table to make the prediction. Next, we'll predict its reactivity, so we can see that all of the things in the same group have low reactivity. So I'm going to predict that it has low reactivity. And finally, our conductivity. We'll notice that the first thing was an insulator, but then right above it and right below it are conductors, and to the left and right of it are conductors. So I'm going to predict that it's a conductor. So you're going to make the predictions for all of the elements, the other examples that you have, and then I would like you to look at online at an actual periodic table and see if you can fill it in, the actual, to see how your predictions go. Okay? Because your predictions are based on what the trends are showing, I would expect that your predictions and the actual values will be different. Remember, I'm not looking for a perfect value, I'm looking for one that follows the patterns.